Hi students, in this video we are going to see about 6th lab program in C programming laboratory. The title of the program is binary search. Let us go to the question. Introduce one-dimensional array manipulation and implement binary search. This is my question. So here they have asked that introduce one-dimensional array of some elements, and using that one-dimensional array we need to perform the binary search application. Okay. So let us go to the meaning of array. What is meant by array? Array is a sequenced collections of elements which are stored and represented by one single name, single variable name. Okay, so it is a sequenced collection of elements. Either it may be stored in some order, either ascending order or descending order, whatever the order they are following. It is a sequenced collections of elements of same data type. So this is the definition of array. So now we are going to get one sorted array. Like either it may be in ascending order or it may be in descending order. We are going to get one array of some elements of the same data type. Using that input, we are going to perform the binary search. That means we are going to find one element present in the array. So this is my concept. So let us go to that logic of binary search. So this binary searching algorithm is a fastest and simplest algorithm. It is a simple and fastest algorithm, but the condition is this algorithm will be applicable only for the sorted elements, either in ascending order or in descending order. So this will not be effective and this will not be applicable for unsorted elements. Okay. So this is the condition for this binary search. With this, we will see how this binary search will work. You see the picture 1, 2, 3, 4, 5, 6, 7, 9, 8 is my element. Here these elements are ordered in either ascending order. So how this binary search will perform means, first it will fix the first element. It has 3 variables, 3 points to perform this search. First point is low, and second point is high, and third one is middle. So these are floating variables. This position will change, this value will change during the searching techniques. So first initially, before going to perform the search algorithm, first these fields are initialized. How this will be initialized means, low in the sense, this field, this variable will be fixed at the first element. This low field will be pointed the first element of array. Then high variable will fix the last element of the array. Likewise, in the diagram also it shows like low is pointing to the variable value 1 and high is pointing to the value 9. Then after these two and are fixed, then middle value is calculated according to the value of low and high. So what is the formula for calculating the mid means? Middle equal to low plus high divided by 2. Likewise, first these 3 variables will be fixed before going to perform the binary search. So first, after getting the input variables, after getting one sequenced collections of elements, these 3 values first at initial step, these are fixed. Then how it will be performed. So now I have taken one example of sequenced collections of elements which are arranged in ascending order. So first element is 1, the second element is 3, third element is 12, fourth element is 14, likewise it goes on. So in the first step, I need to find out 75 is present or not. So my searching key point is 75. So if the 75 is present or not is my condition. So how we can perform? In the first stage, in the first pass, what it will do means the low value is fixed on the low 0th element, because we know that the array will start from the storage location of 0th to till the end of the elements. So for always the first location will be 0. So in the low point will be fixed here. So 0 and high point will be fixed in the 9th location. So this with this value 0 plus 9, this middle value will be calculated. So mid equal to what is the mid? 0 plus 9 divided by 2, that is nothing but 4.5. When you are flooring it, it will have 4. So this floor 4 is my midpoint as of now in the first iteration. That is what it is given as iteration 1. Now this midpoint is found and low and high and all fixed. So after fixing of these three values, now we are performing whether this searching keyword is between the left part or right part. How we can find? Because we know that this input elements are sorted in either in ascending or descending way, it is sorted. That is the advantage of this one. So we need to divide this entire array into left part or right part according to the searching element. Now my searching element is 75. Now we have to perform A of mid. What is the A of mid? 23. So we have to compare this searching value with mid value 20, whether it is greater or not. So if my searching point is greater than the A of value, we need to traverse in the right side. That means this array element is this array is stored in ascending order. So the next element will be the highest element. So my searching element is 75, mid value is 23. Obviously this 75 will occur in the right side of my array. So I need to focus on right side, no need to focus on left side. That will be the waste of time. Okay, so first in the first iteration itself, the searching key is compared with the A of mid. In the first iteration, what is the value of A of mid is 23. So 23 is compared with 75. Now 75 is bigger than mid. Now we got that this searching element should be in the right side of the part. So that's what in the second iteration, again this low value, high value and mid value is reinitialized. How we can reinitialize? Because when we move on to the right side, this high value still remains same. No need to change the value. But low value should be changed because we divided the entire array into right part array. So the low element is now fixed with A of 5. That means A of mid plus 1. Then high value will be fixed the same. Then with 5 plus 9, we need to find out the mid value. Now we got the mid value equal to 7. Mid value equal to 7. So after reinitializing everything, now low value equal to 5, mid value equal to 7 and 9 is the high value in the second iteration. Now we got the values. Next step is we need to compare the searching value with A of mid. Now what is the value of A of mid? 65. 65 is compared with 75 in second iteration. Now in the result also 75, my searching key is greater than the A of mid. So what happened? We need to traverse one again to the right side only, not to the left side. If it is lesser, we need to traverse to the left side. But now my searching key is greater than A of mid. So we need to traverse in the right side. Again in the third iteration, we need to reinitialize everything. Still the high value will not be changed because it is traveling in right side. So no need to change the high value. We need to reinitialize the low value. So low value will be mid plus 1. Now low value is equal to 8. Mid value is also 8. So we are checking the value of A of 8. A of 8 is 75. My searching key is also 75. Both are matching. Now we got that 75 is present in the location of A of 8. So my search is successful now. So I can come to the result of that. My binary search is successful. I found the location of searching key at 8th location. So this is my logic. With this logic, we are going to write a C program. Okay, so coming to the C program, first steps are inclusion of header file. Then say after the void main, we need to initialize the variables which are required for this implementation. So first, what is the my input? Input is array. Array is declared as a 50 as a default size of this program. So array of 50 is my input. And then how many length of that array should be also a input. And then I is the intermediate variable. Then 3 variables should be declared. First, last, middle, where we in the theory we have seen that low, mid and high. So here it is replaced as first, last. So first is nothing but low value and last is nothing but high value. Middles are same. And then one more input we need to get searching element. So say for example in the last example 75 is my searching key, we know. So likewise I need to get the searching value. So these are declared in this statement. Then coming to the input part. So what is my input? First is length of the array. Length of array is my first input, that is stored in the variable n. Now we got the length of the array. Say for example, I need to give the 10 input elements of 10. 10 input elements I need to get, means the length of the array is 10. So I need to get 10 elements. So this can be achieved with the help of for loop. Starting from I equal to 0, I is less than or equal to n, I plus plus, we have started my for loop. Then in the for loop, I need to get 1 elements. So those elements, those sequenced elements should be stored in the array of variable called as ARR. Okay, so ARR is my variable name. In each consecutive elements will be stored in that name ARR. So in this scanf statement, it has been written like %d is my format identifier, ARR is my variable. In that way, I have got my 10 inputs. After that, I need to get the searching element. Which element I am going to search? So that should be stored in the variable called as search. So this is also have to be got from input. So using the scanf statement, this should be read from the keyword. So scanf statement is written like that. Then next, coming to the logic. Before going to implement the logic, I already told that first is denoted as 0 and last is denoted as n minus 1. So in this case, what is that part? So first is 0. That means low value equal to 0 and high value equal to 9. No. So in this way, so first equal to 0 and last equal to n minus 1 is declared, initialized, and middle also should be calculated. So middle is equal to nothing but first plus last divided by 2. So these three values are initialized. Then using the for loop, if first is less than or equal to last, I need to do this in a repeated way. So in this way, how we can do means using the while loop only. So what is my checking condition? If the first value should be less than or equal to last. Okay, so that means that till all elements are searched, so this should be carried out. For this, I have made one condition that first should be less than or equal to last. Then now we found the middle value, it should be checked with the searching key value. So if ARR of middle is less than or equal to search, I need to traverse in a left hand part. In the left hand middle is less than, right. AR of middle is less than or equal to search means that searching value is greater but middle value is lower. So that part I need to traverse in the right side. So right side, when you are traversing through the right side, no need to change the highest value, last value, you must rechange the first value. So for that only first equal to middle plus 1 is given. Okay, then else if AR of middle is equal to search means search is successful, it is in the location like this. So this has been written. And then or else if the search element is lesser than the middle element, we need to traverse in the left side, and that position no need to change the first element, we need to change the last one. So last equal to middle minus 1. Okay. So in this way, these three cases are applied, and for each iteration, this middle value will be changing on. How we can calculate means according to the current value of first and last, we need to add the value of first and last divided by 2 is my middle value. Last, in all cases, my search element is not present means and that position I need to tell that the search is not successful, not found. Like that I need to convey this information. No. So for that I have made one condition. If first is greater than last, printf not found, this keyword, this searching element is not present in the list. Like that I need to convey. So coming to the program output. So here I have taken the screenshot of how we can execute this one. Now it is asking us enter the total number of elements. I have given 5. So 5 elements needs to be read one by one. So first element is 12, second element is 23, third element is 34, and fourth element is 45, and fifth element is 56. Like that I have given the 5 elements. Then enter the elements to search or find. So my searching element is 34. 34 is in the location of 3 is found because 34 is present. Okay. So this is my output. Coming to another set of output. Again the total element is 5. I have given some 5 elements. They enter the element to find, but I have given the element which is not present in the list. So for this case, what it will display as output means not found, because 6 is not present in the list. So this is also search unsuccessful. Search is unsuccessful because that 6 element is not present in the list. Okay, so these are the two variable possibilities of outputs can be represented in the binary search program. I hope you understand this logic. I'll catch you in the next video about next lab program. Thank you.